Hi everyone, my name is Mohammad Khajuriwala. Welcome to my channel. In this video, I'll show you how to create an AI assistant with the help of AWS Bedrock. So by the end of this video, you'll understand how AWS Bedrock works and how you can utilize it with other AWS services like AWS Lambda. So let's just dive in. So starting with what AWS Bedrock is all about. AWS Bedrock is a fully managed service launched by AWS, and it's like a powerhouse to your AI projects. It provides access to high quality foundation models like AI 21, Anthropic, Meta, and so on. So you can use these different models according to your requirement. You can even use multiple models together if that's your requirement. So AWS Bedrock comes with a lot of capabilities, but the two most important that I think is customization and security. You can customize your models via fine tuning and RAG. And second is the fact that the data that you use is completely in your control in your AWS account. So the kind of prompts you use and the data that you provide to AWS Bedrock is not used by AWS to train its basic models, which can be the basic requirement while using it for enterprises. Now, today I'm really excited to walk you through how AWS Bedrock can be used in a serverless way, in the way that AWS Bedrock is generating a response and the response is streaming to the user in a serverless manner. So, in order to understand this, we'll be looking into three concepts. One is what AWS Lambda function URL is, which will be used to invoking the AWS Bedrock. It generates a HTTP endpoint for us. Second is AWS Lambda response streaming. So basically, the response is streamed from the backend service to the user using this functionality. And third is Anthropic Cloud V2, which is the foundation model that we'll be using uh, behind AWS Bedrock. So that is what we'll be discussing today. So now let's jump into AWS function URL. In a serverless world, when we think of exposing AWS Lambda via an endpoint, we generally think about API gateway within our design. Now, AWS Lambda function URL just does that for us. We don't really need an API gateway. We can directly access the AWS Lambda via a dedicated HTTPS endpoint. And this is like a game changer for organizations using microservice architecture, since it simplifies the design and the cost by omitting API gateway altogether. Now, in our design, we'll be using this to uh, access AWS Bedrock behind the scenes. And we'll be doing this by generating a resource in our SAM template. Plus, we'll add a layer of security with AWS IAM, ensuring only the authorized users can trigger our endpoint. Moving on to the second pillar of this design, which is AWS Lambda response streaming. AWS Lambda response streaming is a feature introduced by AWS, which comes with two significant benefits. One, it significantly boosts the time to first byte, which makes the applications to load faster and become more responsive. And the second benefit is that it enables the users to generate larger responses. Now, AWS Lambda has a limit of generating 6 megabytes of response, but with this feature, users can generate a response with a soft limit of 20 megabytes, which can again be increased by sending a request to AWS. Now, in our design, we'll be using this to make the AWS Bedrock generate responses via AWS Lambda and send it to the users in real time. So if you have been using ChatGPT, you will be seeing that the response is getting generated as and displayed to the users in real time. So similarly, we'll be seeing in our application, which is by using AWS Lambda response streaming. Now, in order to enable this, we'll be making two changes. One in our SAM template, which is we'll be making the invoke mode to stream mode. Now there are two modes that we use in AWS Lambda. One is buffer mode, which is by default, And in order to use the response streaming feature, we change that mode to response stream. I'll be showing this to you in the code. And the second is that in our Lambda code, we'll be using the Streamify response decorator. So by using this, the Lambda understands that the response has to be streamed back to the user. So by doing these two changes, we'll be introducing response streaming in our design. Let's look at how to configure AWS Bedrock within the AWS console. So if you go to the AWS console and to the Amazon Bedrock service, the first thing that we will be required to do is to gain access to the different models that we will be using. So if you go to the model access page, these are all the models that you can gain access to. And we will be using Anthropic because Anthropic supports streaming, and streaming is one of the core functionalities that we will be requiring within this particular design. So that is the reason we'll be using Anthropic. So you can go to manage model access and you can raise the access for different models out here. Once you have gained access to it, you can go to playground section. You can go to text, select the Anthropic Cloud V2 model, and you can play around with the model in this particular window. So you can see different configurations out here towards the right, which can be useful in order to control the way the model generates the output for you. So the models basically use probability to generate the next word within its response. So these parameters, temperature, top P and top K, are the ones which are responsible to control the way the model generates the output. So you can go out here, you can look into the info and get some kind of idea how this works, and you can configure it in different ways and see what works for you the best. So, and the last one is the maximum length. So the amount of response that it generates, you can control the length of it with the help of this particular parameter. So you can write the response out here, write the prompt out here, like whatever you want to try. And the other thing is you can go to this particular drop down and you can view the API request. So this is how the request needs to be created when you're using it within your application. So you can copy this request and you can use a similar can create a similar request within your code. So this can be really helpful in order to get an idea as to how you need to code it within your application. Now we have seen how Lambda function URL works, how response streaming works, and how exactly to configure the AWS Bedrock within the AWS console. Now let's just dive into the code and see how everything fits together. So when we talk about the code, we have a SAM template and we have our Lambda function. Within the SAM template, we are generating two resources. One is the Lambda function. So this is the code where we are configuring the Lambda function. We are setting the runtime as Node.js. We are configuring the memory size and the timeout. And we are attaching an IAM policy which enables the Lambda function to just communicate with the invoke model with response stream API of Bedrock. Also, we are making sure that the Lambda function is only able to communicate with Anthropic Cloud V2 model. So we are making sure that the IAM policy has only the required kind of permissions. Also, we are creating the function URL. So this is the code where we configure the Lambda function URL and we are making it response stream. So the invoke mode out here is response stream. And that's it with the SAM template. we are generating the AWS Lambda URN out here. So the SAM template gives us the URN is in the output as well as the function URL. So this is where we generate the function URL. This is how we know how to communicate with our Lambda function. So that will be using the function URL. So now if we look at the Lambda function code, the code is pretty simple. It's kind of divided into 2 to 3 parts. The first part is where we have this streamify response decorator. This decorator is useful for us so that the Lambda code understands that it needs to stream the response back to the user. And this is something that we defined as part of the response streaming feature that we have. It gives a response stream as an input parameter. So whatever data that we want to send back to the user, we pass it to the response stream. After that, we have the request body that we create. So the event that we get as input from the user, we take that event, we take the prompt inside that event. So if you look at this, this is where we have the event.body. We capture that into the request body variable. Within the request body, we have a prompt and we capture that. And we use this prompt to stitch it into the request that we are sending to the AWS Bedrock APIs. Now, this is the API request, exactly similar to the API request that we just saw a few minutes back within the console. And this is where we are stitching the prompt inside. So if we look at this, we are configuring a few parameters out here, like the max token to sample, the temperature, the top K, the top P. These are some of the parameters that we just saw. The stop sequence, and generally all the information that we require so that the AWS Bedrock API understands which model it needs to invoke. And every model has its own way of defining these parameters. So it's best to take the API request from the console and then form your own request out here. So we can see that we are defining the Anthropic Cloud V2 model out here. After we have constructed the input out here, we pass it to the invoke model with response stream command, and we send this request to the AWS Bedrock. Once we receive the data from AWS Bedrock, we receive it in the form of chunks. Since we are using the response streaming feature, we receive the data in form of chunks, we transform that, and we give it back to the user. So we are using the transform stream out here, where we are getting the data from the AWS Bedrock API. We capture that data and we take the chunk from within that data and we take the bytes from it. We pass it out here so that we are passing it to the user in the form that the user understands. That is plain text. So basically we are taking this chunk of data, which is in the form of bytes, and we are converting into text. And once we convert it to the text, we are pushing it within the stream. So it's like we have a pipeline of streams. One is the stream that we are getting from the AWS Bedrock. Within the transform stream, we are transforming the data, we are getting that data, we are transforming it, and we are giving to the response stream from where the user captures the response from the Lambda function. So if we look at this one, this is where we can see that, the pipeline is getting the data, we are passing it to the transform stream where it is getting transformed, and finally it goes to the response stream. So it's quite simple, and Node.js makes it more simple for us since it's able to get the stream and transform it and send it to the next stream. So the main things that we need to look at out here is the streamify response, the way we need to construct the input, and maybe you can go and just understand how the transform stream works, so you would understand how we are transforming the data and sending it back to the user. Let's go ahead and run the project now. Let's open the terminal. So the first thing you can do is build the project and then run the sam deploy command. Now since I have already deployed this, let me just make some change out here and do sam build. Now once you have built it, you can run sam deploy. If you're deploying it for the first time, you can use sam deploy guided, and it will give you all the options that you need to select, and it will guide you through the process. So you can do sam deploy. So we'll say yes, deploy your changes. So yep, this is the output that we get. One is the ARN, the Lambda ARN, and the function URL. So once you have this function URL with you, you can go to the readme section. So I'll be putting the links to the codes in the description below. You can take it from there, and you can replace this function URL out here, and you can run the curl command, which will run this which will run the prompt, and you'll get the answer out here. So you can use curl directly and you can get the response. One thing that I would like to mention is you need to use this no buffer parameter, and if you don't use it, it won't look like it is streaming the response back to you. So what curl does it is it buffers the response and it just shows you directly towards the end. So it won't look like it's streaming the response back to you, but internally it is. It's just that curl doesn't give the response back to you directly. It waits for the buffer to accumulate in the entire response, and then it displays it to you. So if you use this parameter, it will behave the way you want it to. Now guys, once you have deployed the code via SAM and you have got the function URL with yourself, you can either use it via curl, or you can create your own front-end application and enjoy your serverless assistant. So in my case, I am just using Python Streamlit, which generates a chatbot kind of a front end for you, and you can just write any prompt you want out here. Maybe we can write what is AWS, and this is how it generates the response for you. So it's streaming the response back from AWS Bedrock via AWS Lambda. And if you look at it visually, this is what is happening behind the scenes. The user sends a prompt to AWS Lambda, which is sent to AWS Bedrock, and AWS Bedrock responds back in the form of chunks. And we are just transforming it and sending it back to the user. So yeah, this is exactly how it works. You can also see the logs where AWS Lambda is creating the request for AWS Bedrock and sending it back to AWS Bedrock and receiving the response. So yeah, guys, this is really simple, and this is what it looks like. Now that's all for today. That is how you use your AI serverless assistant with AWS Bedrock. But that is just one way in which you can use Bedrock in your design. There are a number of ways that you can use it. Put your comments below the way you use it. Like the video if you like the content. Subscribe to the channel. And all I ask is to share with those interested to learn more about AI and serverless. Thank you.